Hola amigos! In today's Houdini tutorial, we're going to continue exploring the concepts that we learned about in the first video and make this cool animation of a bunch of paper planes flying around and dispersing. So without further ado, let's get started. I've already removed a bunch of the tabs here, and remember from the first video, if you hit P on the keyboard, you can hide or show the properties viewer. So let's start by creating a geometry node first. Remember, press tab or right click and look for geometry, and let's call this paper plane. So how to make the simplest plane ever? So let me draw a curve first for a moment and enable the handle operator, and now we can draw a curve. So if you think of a paper plane, it's basically this curve. Well, let's do something prettier. It's something like this, extruded to a point. So if we were watching it in like a perspective, it would be something like this, right? And maybe you want ailerons on the side, something like that. Whoa. So let's do this, but instead of drawing a curve, which you see how it goes manually, let's do it programmatically. So curve is basically a line, so let's start with that line. Now we want this to go on the Z axis, so let's change the direction to 0, 0, 1, and now curve goes in the Z axis. Cool. Now let's center this so it's a bit nicer on the whole geometry design. And we could do that in a couple ways, but let's highlight the coolness of Houdini by doing it again kind of programmatically. So we can take this parameter, which is the length, and if you think of it, to center this line, we just need to move it half of the length in the opposite direction, right? So let's do that. Let's say we want this line 0.5. So now we can copy this. So right click, copy parameter, and then go to the origin Z value, remove the 0, and right click and click on paste relative references. And now you see it says channel distance. That means it's taking this value. And now you can see it moves away as we change the length. So, but we don't want that. We want half of that in the opposite direction. So we can multiply this. So times minus 0.5. Boop. And now it's center, and it stays center. And now you can see this channel, this parameter is green because is referencing this other property. And now if we click on origin, we can change from the code to the actual value. So let's go back to 2.5 and zoom in a little bit. So let's enable point visualization for a moment. So we have 2 points, and if we wanted more detail, obviously we can increase this, let's say 20. Problem is, if we change the length, now our points might not be distributed in the same way, or we don't have, or they're distributed in the same way, which means we don't have enough detail on our curve. Oh, and do perfect. So let's fix that with a resample node. So look for a resample and connect it, displayed, and now we can change this length property here. Let's see, let's see for a moment 0.01. And now you see we have a ton of points. We don't need as many, so 0.05 to make sure that whatever distance we have decent point detail. So, okay. Now, one extra thing that we get from the resample that we get for free, it's a index on each point that tell us how far is from the origin of the curve. So think of it as this being 0 on this side and going all the way to 1 on the other. And it doesn't matter how long is the curve, it will go always from 0 to 1. And that's the curve U attribute. And if we click here on curve U attribute, we can enable it and change the name, but just leave it as curve U. So now we can go to the geometry spreadsheet, and now we can see that our points have position, which is the uppercase P, X, Y, and Z, and now it has a curve U that goes from 0 all the way to 1. Cool. That will be useful later. Now, let's move these points to match the profile that I drew earlier. We'll do that with a little bit of code, but don't worry, it will be quite simple, and I will explain all of it step by step. So in Houdini, you can run code over parts of a geometry like points, edges, or primitives with what is called an attribute wrangle. And you can create an attribute wrangle, or which is a little bit of a shortcut, a point wrangle in our case, which is just an attribute wrangle, as you can see here, but run over points by default. So it has 4 inputs. Let's connect our resample to the first one and enable the display. So our points, let's go back to the geometry spreadsheet for a moment, have, if you remember, our P variable, which is the position, and a curve U. So if we want to move the position, for example, we can get the position, which is, it's a vector, so let's start with V, and then it's an attribute from the geometry, so we need to type add, and then the name of the property. So V add P represents this property that we saw in the geometry spreadsheet. So let's add to that a new vector, and you specify a vector by using the set expression and then set parentheses, let's say 0, 1, 0. So now all of our points move 1 in the vertical space. Cool. So let's change that into a variable. So we're going to call that, and it's a new variable from this code, so we need to create it here, and it's going to be a float. So float offset equals, and let's keep it at 1.0, and then replace this 1 here with offset, and nothing happens. Now let's change this number, so we can change it with a slider here. And we could do this manually by going here and parameters and channels and going to edit parameter interface. But this button here will do it for us. So let's see how. Let's remove this 1.0 and type CHF. This represents channel of the type float, and then parentheses, and we need to give it a name. So between quotes, a scale. And now it goes back to 0, nothing happens. But if we click this button, now we have our scale slider. And we can move this up and down. Okay, that's pretty cool. But what we want, really, is to match this to the profile that I drew earlier. So let's see how can we add something like that, like drawing a profile here as a property of this. So let's keep this and rename this as float scale. And then it will give you an error if you just click outside because offset doesn't exist. So let's add a new variable, float offset equals, and the type that we need is called a ramp. So ch ramp. And then this one needs 2 parameters, as it says here. So one is the name of the ramp, and the other is the position of the ramp, or the index. So let's give it first a name. We'll call it shape between quotes. And from the index, remember that curve view that we saw earlier. That's what we are going to use. So it's a float, so f at curve view. And then close the parentheses. And now we don't have an error and nothing happens, but we can click this here again. And now we have a curve. And as you can see, what we have on the viewport, it's actually matching what we have here. So yes, all we have to do is go here and we can add some points. Something like that. Or even you can change this interpolation to be a spline. We're changing all of them. And maybe add one more on each side. Yeah, something like that. Cool. And now we can even reuse this scale because we can scale this and say, for example, offset times equal scale. Oh, sorry, we need to create this value before we use it. So I'll cut it from here, paste it here, and let's clean this up. And now if we increase the scale, this changes. But it goes up, so we can also compensate for that by taking the scale of the final position. So it will be offset minus scale. And now our plane, no matter what scale we set it to, it will be always centered on the grid. And we can change this to be bigger if we want a crazy looking plane. And let's keep it at 1. Like that. And now we could add, and let's do it, another resample. So we resample and we redistribute our points. So let's go back to 0.05. Perfect. Now we're ready to extrude it. Now poly extrude. See, the code wasn't too difficult. And connect the poly extrude, enable the display, and if you increase the distance, this is not what we wanted. Now the easy way to fix it is to change the extrusion mode. Instead of primitive edge normal, we want to use the point normal, and our plane is starting to take shape. So let's increase this, maybe 3 times 2.5. Yeah, that sounds like a paper plane. And now we can go back to the resample, to the point wrangle, and maybe decrease the scale a little bit. And now, there we go. Sometimes it doesn't refresh. Don't worry about that. If that happens to you, you can just create a new scene view. So click on the plus icon, new paint tab type, viewers, scene view, and all the visual glitches will be fixed. Okay, so back to the poly extrude. We want this, but we want it to go to a point. So let's go to spline control, scroll down a little bit, and we have here the thickness ramp. So if we take the back point and reduce it, now our plane looks like a plane. And let me change this to linear, also here to linear interpolation. And one thing that you might try is to give it a different profile, like something like this. And nothing is happening because we don't have enough divisions in this axis. We can change that here on the extrude properties, increasing the number of divisions. Let's say 20 maybe, yeah. And our plane matches this. Now we want to give it, I want to give it a little bit of thickness, so we can now do a second poly extrude. Connected. And on this one, we can keep the extrusion mode as default and increase this to maybe 0.03. And I don't want the plane to be hollow, so click output back. And this looks pretty cool. Now if we go to the front, there's a problem here because we still have a ton of vertices coming from the previous poly extrude. But we can change that by adding in between these two a fuse node. And click here and maybe increase the the snap distance a little bit. Oh, I think it's happening again. Yep. Yeah, sometimes the geometry doesn't refresh correctly, so I can close this all the same view. But yeah, after the fuse, and if I disable, hopefully it doesn't explode. Yeah, you can see that it fixes the problem. Cool. We could even add a bevel if we wanted to round the edges or figure out a way to add like folded detail or even simulate the folded detail. But again, I want to keep this tutorial simple. What we could also do is, I don't know, let's say we move all these points down a little bit, except the ones on the final edges, and we keep more or less the symmetry, and we get something like that. I think I like it. Yeah, I think I like it better. Yeah, that looks like a pretty plane. Cool. So now we can go back to the object and look at it. Oh, actually, before that, we are going to use this later on, and we can reference a node when we use those operations. And I don't want to remember that is the poly extrude 2. So let's add an empty node, which is called a null node. So this node doesn't do anything, just is just an extension of whatever comes before it. But if we give it a name like out geo, now we can, when we reference this, we can remember easily that paper plane / out geo is what we need. And also because the way Houdini works, out geo will be usually at the top of any list. So, okay, so we have our paper plane, and because of the way we created it, the pivot point is also centered here, which is going to be useful later. And we want now to move it and simulate a bunch of them moving around. Now, we could simulate this and calculate the dynamics and the lift of a paper plane flying around and the collisions of all of them, but it would be quite complicated, and it wouldn't be definitely a real-time tutorial. So let's do a bit of a shortcut and copy the motion of something else that we simulate. So let's click here and disable the geometry for a moment, move it a little bit out of the way, and on the Pyro Effects tab, click on Sparse Billowy Smoke. Now we need to place it on the viewport. I'm still going to move it to 0, 0, 0, so go back to the object level and click on the billowy smoke and move it to 0, 0, 0. Let's take a look at what we have here. So if we hit play, we have a donut of a smoke that rises up, emits some smoke, which rises up and dissipates. Okay, this doesn't simulate in real time, but it's not too bad. I'm going still to click on FPS here, well, this icon here in the bottom corner, and set the FPS to be 30, and then apply FPS to retime everything, and then resimulate a little bit. So what I want to do is I want to take some data from this simulation. I want to take the velocity of the vortex of the voxel field and the density of the voxel field and apply that to a set of particles. And then we'll replace those particles by perfect planes. This is not going to be technically accurate, but it's going to be a pretty cool effect still. So if we go to the geometry node first, we see that we have two groups of nodes. Let me move this one a little bit, and then we organize this a bit more. Okay, so this first group is the source. And actually I'm going to add a comment here and double click and call this source. Now if you hit C on the keyboard, it will hide or display this color box, and now we can click on any node or the comment box and change this to purple. And this second group of nodes is rendering this as a smoke. So let's change this and change this name to render and pink. Perfect. Okay, now I want to tweak this smoke a little bit. First, I want to change the shape of the emitter. I want the hole in the center, so let's make just a box. And now replace the pyro source. Sorry, before that, let me rewind a little bit so we can examine what we have here. So we have a torus, just a donut, that then is passed as the pyro source, which is basically taking that and sampling it as, or displaying it as particles, or creating particles throughout the whole volume of the object. Next, we have this attrib adjust vector velocity, which is just adding some initial velocity, in this case 0, 1, 0, represented by this attribute name called v. And now actually if we go to the pyro source and to the geometry spreadsheet, we have our properties here. We have our position, density, p scale, temperature, and group. Don't worry about that, but if we go to the next one, now we have a new property called v, which is a vector, x, y, z, and it has some random values, some noise values. And if we hit play, those values are changing over time. So back to the scene view. And now the next thing after that is a volume rasterized attributes. This is basically creating a voxel field out of these properties. So if we hit play here, it's going to be very difficult to see, but this cloud is changing a little bit. The density of it is changing a little bit. So that's why the noise, or sorry, the smoke, when we play it, is not perfectly shaped. It has some turbulence, but I don't think it's enough. So let's add a little bit more. So first, as I said, I'm going to change this torus shape. So let's remove the torus. Now everything has errors. Don't worry about that. And add a box. I'm going to rewind here so it doesn't simulate everything. And now we have a box of smoke. Cool. Now I want this box to be differently shaped, so let's change this size to x 0.1. Oh, and then rewind it. So now we have a flat, kind of thin paper sheet of smoke. And I want this to be center, so let's do the easy way. So match size, and like we did in the first video, and justify y to minimum. And our box is sitting on the grid. Next, the pyro source we can leave as it is. We could increase the detail of this particle separation, or increase the detail by reducing the particle separation here to 0.25, but 0.5 0.05 is not too bad for the simulation. And again, we don't care about really the quality of the smoke visualization. It's more what we want is just the velocities, and that will be enough with this amount of particles emitted. Next, I want to change this velocity, initial velocity, so it's on the x-axis. So now let's change this to maybe 2, 0, 0. And now if we go back to our render here and enable this, our particles move more in that direction. But the buoyancy of the smoke is still making it rise. So let's change that later. And now add a little bit more noise to it. So if you look at it, still pretty, like, I don't know, pretty symmetrical, and it doesn't have a lot of detail. So between this velocity and the volume rasterize, let's add a volume velocity node. Put it here, and it has a bunch of parameters. Don't worry too much about them. We can add vortex, and actually let's see how it is if we add vortex, and then curl noise. Yeah, it breaks a little bit earlier. And especially afterwards. Yeah, I think this is pretty cool. And it will be enough for now. You can change this later. Actually, you can, yeah, you can change this later and change the scale of this noise or the size of the swirls. Let's keep it at default. And actually, I'm going to increase the turbulence here, maybe 5. Let's do 10. Yeah. And maybe reduce the scale because we have a very small cube. Cool. Okay, I think that will be enough for now. Now, next thing I want to do is change the gravity, or at least the buoyancy, so it's negative. And instead of floating up, it falls down, like paper planes would do. So go back to the object level, and next we want to do that on the simulation. So here we can go inside the below smoke simulation and start tweaking some parameters there. First, we need to take a look at what we have here. Okay, so we have a pyro object, which is a smoke object, that determines some of the aspects of the simulation. We're not going to change anything on that one. Here we have the source of the pyro effect, which, if we look at this line here, it's taking the volume rasterize attributes, which I'll show you for a moment. It was the last node on this chain here. So, go back. Okay, so here we don't have to change any parameters for now. But here on the pyro solver, I want to change a couple things. So I want to keep the gravity as it is, and we could reverse the gravity, but I want to change the buoyancy instead. It's kind of the same effect, so don't worry about that. Okay, now the smoke falls down. But I want some collision, and we could do that the same way that we did in the first tutorial, by going to collisions here and adding a ground plane, but don't do it instead. Don't do it yet, because instead we're going to create a very simple background object. So going back to the object level, tab, geometry node, and let's call this one background. So yeah, with a bit of smoke, so we can see how big our scene is going to be. And actually, if you don't see it, just click on this button here, and you can switch between show, ghost, or hide other objects. Let's keep it on show so we can make sure that we see some of the smoke. So let's start by adding some ground. So add a grid, and I'm going to change the size of it. So let's do it with the handle, and take this one and maybe make it, yeah, like something like that, maybe a bit wider. Yeah, I think this will cover a lot of it. And we can even move it a little bit. We're going to use these two sides as the walls. So now I'm happy with it. Now right click and or tab, and we are going to add a poly extrude. So add extrude and select poly extrude, and connect it here. And now we don't want to extrude the whole thing. We want to extrude so only these two edges. And because we don't need also all this extra detail in these two in these two dimensions, we can go back to our grid and change the columns to 2 and the rows to 2 as well. And now we just have one plane. Back to our poly extrude, we could create groups and assign them here using this drop down. But we can also click the arrow and create these groups manually or only for this operation. So click here, and then on the top row of icons, select the second one. So we select edges and select this one and shift click on that one. And now these two ones are highlighted in yellow. Hit enter, and now we have our group here, P01, P20. And if we increase now the distance, it's extruding, but similar to what happened earlier with the plane, it's extruding in this axis, which is not what we want. But again, same fix as earlier, change this to point normal, and now it goes in the correct direction. And we can change this distance to maybe 5. So if we want to render it later, we have some nice background to it. Now, we want to use this as a collision, and since we're using smoke and voxels, we probably want to give it some thickness. So we can do that by, before that, I think I'm going to soften these edges. And the easiest way to do that would be with a poly bevel. Enable display, and then you can increase the distance a little bit, maybe a few more divisions, maybe 2. Oh, 2. Yeah. And change this to a smooth shaded. Yeah, it looks okay-ish. Okay, so as I was saying, I want to give this some thickness so the collision behaves a bit better, or it's easier to simulate without a ton of sub-steps on the actual simulation. So let's add a second poly extrude. Connect the first one, and on this one, we don't have to change the extrusion mode. However, I think, I don't want to move it down manually, and we could do it by moving manually this exact amount, but I want to extrude it on the opposite direction. So let's say 0.5. Cool. Now we have this, and we can output the back, and as you can see now, the next problem is that our normals are reversed. That has also an easy solution. We can type reverse and connect this node, and boop, our normals are fixed, and the faces are facing the correct way. Next, go back to the object level. So I'm going to do the same thing I did earlier. If you remember our paper plane, we have our null out geo here. Do the same here. So add a null, and we'll call it out geo. And we can click on the display flag for this one. Cool. Now with this one selected, we can click on the static object, and now our object has been added as a collision. So now we can rewind and hit play, and our object, or smoke, sorry, spreads on the floor. I think that's pretty cool. And again, I think it has enough detail for a ton of paper planes. It doesn't need more granular detail. Okay, next we can go to the smoke simulation and see what happens here, because we have a few new nodes. So let's select these three over here and move them to the other side. So we have our static object, which is our background, and we can see this address here, which is a little bit weird, but if we go to our background, we can see that it's because it added a couple nodes. Don't worry too much about them. This is mostly to cache the collision on disk if you want. Back to our smoke simulation, we don't need to change any parameters here on the static solver or the background. These bounds and these properties are okay. And cool. So now we have our smoke and we have our paper planes. Actually, let me go here, and I think I'm going to, yeah, we can go here to the shape, and I'm going to maybe, I don't know if decreasing the wind and then adding more velocity. Yeah, I think I like this, but I'm going to change the turbulence to maybe 1. And then replay it again. Yeah, I think a bit more chaotic will be fun for the paper planes. Yeah, you can play with all these values and change all of them and get completely different results. Okay, so maybe if you are an expert in Blender or Maya and you've been following this tutorial, to this point you might be thinking, well, I can do all of this in my other software, and why should I learn any of it about this? And the next part is where we show some of the cool magic about Houdini, which is the part where we're going to copy this data and apply that to our other smoke simulation, or to our particles, so we can replace them with the paper planes. Okay, so let me go back. We can go back to the below smoke, and we could do a couple things. So imagine we have our simulation here, which we go back to our render node, which is what we're selecting. Here's our voxel field, very reduced in detail. We could take this and scatter some particles. So look for a scatter and connect this here. So now we are scattering a bunch of particles on the voxels. And if you think like, well, there are a lot of particles here and there should be there, is because there is still some density here, but it's super tiny. It's probably like 0.0001, things like that. And we could fix that and adjust this to actually match the smoke. The problem is that on each frame we are scattering a new set of particles. And that's not exactly what we want, because, well, the particles are scattered randomly, and unless we have incredibly high density, these positions are not going to be temporarily consistent. And the particles are going to be not really moving, but just flashing at different positions over time. So let's not do that. Okay, so I'm going to still add a scatter node. So I could have not deleted the other one. And instead of connecting to the import field from DOPS, which is our smoke volume, I'm going to connect it to the volume rasterized attributes, which is the source volume, or the source for the smoke, which, if you remember from earlier, is this box over here. So now we have points that are scattered on this box. And these are going to be where the planes are being emitted from. So we can change this count to more or less. And if we want let's keep it to 1,000 for now. Oh, sorry, 1,000. And if we want to be more equally distributed, we can remove the relaxed iterations, or sorry, more randomly, or if we want it more, we can even increase the relaxed iterations a bit more. Let's keep it at 10. Okay, so now we have points being scattered on this volume, or sorry, yes, on this source volume. And now we want to simulate them, and to do that we need a subnetwork, more specifically a pop network. And this is going to be basically a particle simulation. Now, before we dive into that, Houdini is basically about two things. One is waiting for things to happen, like simulations and renders, and the other is moving data or copying data from place to place. Many times you use relative paths, like here, object below the smoke, simulation, density. Other times you use the inputs of these nodes, and in this case we have 4 inputs. So let's connect the scattered one to the first input, and these import fields from DOPS to the second one. So we can open the information panel for a moment here. This is a voxel field that has 2 properties, density and velocity. And let's use both of them, starting with the velocity for now. Oh, before that we can alt click here, or any line, and clean up a little bit the graph. So now double click in the pop network to dive into it, and let's see what we have. We have a pop object, which is the data that gets simulated, and we have our source and merge, and then the solver. So in the source we can see that the geometry source, which is what particles are emitted from, it says use first context geometry, and that is exactly our first input here. Now it says on the emission type is set to scatter onto surfaces, but we don't have any surfaces, just a bunch of points. So we need to change this to all points. Now our particles are being emitted from these points. So if we hit play, it goes slow because now there's a bunch of particles being emitted every frame from here. But they are not moving because we are not applying any forces. So let's make some room here and add a pop advect by volumes. What this node is going to do is to sample the volume that we specify and apply that as either a force or a velocity. In our case, we want the velocity. So with the node selected, we can change the velocity source to, instead of SOP, which means putting the path of the node that we want to sample from, we can change this to second context geometry. And from here we can say that the default field name is set to vel, which is correct, and we want to change the advection type to update velocity. And I'm also going to change the advection method to trace because I think it works a little bit better. So we hit play, Now our particles move exactly like the smoke, or more or less like the smoke. Let me zoom out and frame this, and there it is. And in the pop-up vect, we can go to the Guide tab and enable Show Guide. And we can see that it's basically showing a slice of the voxel volume. And the velocity is displayed as vectors here, which I think is pretty cool. Now the next thing I want to do is to add even our smoke is colliding with the ground, right? But the particles they are following the velocity of the smoke, and sometimes some of the particles might still go below the ground. So if we look here at the grid, we can see that some of the particles are moving below. So let's add the collision next. And we could do the same thing as earlier, but we already have the collision here. So if we go to the smoke simulation, we have these 3 nodes which correspond to the background, emerge, and the static solver. So we can copy this, go back to the billowy smoke and our particle simulation, and paste them here. Now let's merge this with the other one. So make some room and add a merge. And connect on one side the static solver and then the pop solver, and then back to the output. And now it's orange because we need to resimulate the whole thing. So if we press play, now our background is here, and our particles should not go below the floor. Let's pause it here and let's look at it. We can even hide the object here if we want. Oh, sorry. Oh, sorry, display geometry. And we can see that our particles are not moving below the grid. Perfect. Now back one level. Oh, sorry. And yeah, oh good. There we go. There are particles. Now the next thing I want to do is stop them after a while, because if we just let this go, let's say 90 frames, 3 seconds, and let's add a no here. We can see that we have 92,000 particles, which still the PC doesn't, once it's simulated, it doesn't go too bad, but it takes a moment to simulate, so I don't want to go it forever, so let's stop it after, I don't know, 60 frames. So let's start with the particles and let's stop them after 60 frames. So if we go here to the output, to the first input, the second tab, birth, the first parameter is called impulse activation. So this turns, as the description says, emission on and off. So think of it as a logic value, and 1 means yes, emit particles, 0 means no, don't emit particles. And we could keyframe this manually, but let's add an expression instead. So if you click on the name, and we type $FF less than 30, now our particles will stop being emitted after frame 30. So what this means is if the current frame is less than 30, so if the current frame is less than 30, this expression is evaluated and returns 1, and otherwise returns 0. So this will be 1 up to frame 29, and up to frame 30 it will equal 0. And we can click back on the name, and we can see that this equals 1, and if we play or simulate Give it a second. Now it equals 0. And actually they should stop being emitted, right? Yeah. So no more particles happen, or new particles happen after frame 30. And the smoke is still being simulated, which we are not using it really, so, or not being emitted after frame 30. So let's go back to the smoke simulation here and change this to be the same. So we have an activation here value, and this means being emitted or not. And instead of keyframing or doing the same expression, let's go back to our particle simulation and then copy this value, copy parameter, right click on impulse activation, copy parameter, and then go back to our object level and then to our smoke simulation, and on the source volume we can right click here and then paste relative references. Oh, and it kept the one, sorry, there we go. So if we hit play now, well, it's showing the particles too. Actually, we can keep both, even if it's a little slower, just to see that it actually matches the movement of the smoke. I think this is pretty cool, and you could keep both things and use it as some kind of debris, extra debris floating on top of the smoke. But I wanted to do paper planes, so let's do paper planes. To do that, we need to go into the below smoke object where we have our particles, and we need to bring our paper plane. So we need to do object merge. So we go here, and on the object 1 parameter we can click this icon here to open the floating browser. And since we were organized earlier, we have the paper plane, and the first node is the out geo that we need. So if I display this, we have our paper plane. Now we want to copy this object onto these points, and to do that there's a handy node called copy to points. Now before we do that, I want to organize this, so select these two nodes and a comment box and call it particles and make it, I don't know, green, yeah, something like that. Now this node has two inputs. The first one says geometry to copy, the second one target points to copy to, and we have a geometry that we want to copy and target points that we want to copy them to. And if we display this, we have a bunch of things happening, and it's giant planes everywhere. And here's the thing, we have points here, but we also have points here. And the second problem is that our planes are magnificently giant. So let's change the second thing first. Let's add a transform node in between the object merge and the copy to points. And let's change the uniform scale to, I don't know, 0.1, 0.025. Cool. Now we have our paper planes, and they are facing kind of this way. And if we run the simulation, they are still moving with the velocity, but they are still facing the wrong direction. So let's fix that. And instead of doing it on the plane, we have a transform here, so we can take the vertical axis on the rotate and set it to -90. And our planes are facing in the direction they're moving. Cool. Now that's a ton of geometry. I could simplify this a little bit, but we'll keep it like that for now. I might do a paintbrush later. Now let's look at the other problem, which is that we still have some points that we don't really want to spawn planes at. Actually, let me change the scale to 0.1 so we can clearly see that we have planes that we don't want to be there. So if we remember, we are spawning the paper plane on the points that are coming from this node. And if we click here to display it, well, this node has the points from the simulation, but it also has the background. And we don't want that. So in the properties, on the first tab, it says object merge, and we are merging right now all the objects coming from represented by this asterisk. So we can remove this, and in the drop down, we have two things, the background and the pop object. The pop object being the particles. So if we click on that, now we only have our particles, and if we go back to the copy to points, now planes are only spawning there. Now we have a ton of planes, so I'm going to change the scatter to be, just for the tutorial, maybe 100, and change this transform to 0.05 maybe. Yeah, something like that. And let it simulate for a moment. And after 30 it should stop emitting planes. Okay. Let's wind. I think this is pretty cool. The motion of the smoke works pretty well on these paper planes, I think. Perfect. Let's show. Oh, there goes the other objects. Now, the last thing I want to do for the tutorial is add a bit of color by randomizing the color of each plane. And that one is pretty easy, because the copy to points node will apply some properties to the geometry that are inherited from the points themselves. So we can add an attribute randomize, and actually by default it randomizes the color represented by this property CD, and we can leave everything as default and just drag it here and between the pop network and the copy to points. And now we have our colorful paper planes. That's pretty nice. Now I want to change the scale too, and we could do another attribute randomize and change, instead of using the CD property, change it to all lowercase p scale. Now p scale is a property that is used by default here, and it's basically the scale of each mesh, and it's a uniform scale, so we can change the dimensions to 1. So it's a float, drag it here, and now each plane is slightly different, which could be cool for variety and to add a little bit of visual interest, but I don't want to do that. Instead, what I want to do is change the P scale based on another property. I want to change it based on the density of the smoke. So they start at the same density, at the same scale, and as the smoke dissipates, the planes get smaller and smaller and disappear from existence. So let's remove this attribute randomize, and let's think about how to do that. So in the pop network, where we were updating the velocity by sampling the volume, another thing that we can do is, if you search for attribute, we have pop attribute from volume. And that's basically the same thing that we're doing here, except that we can customize which attribute to sample or to write. So again, the same as we did here, we want to use the second context geometry, which is our voxel field. So second context geometry, and we want to use as volume name. So actually you can see if we select as volume name the density, you can see that by default our particles are being colored by the density of the smoke, because this is copying that density property to our CD value. But we don't do that. We'll do instead copy to a value, call also density, and make it type float. Cool. So what this means, what this node means, if we go back here, now our particles, if we open the info, now have all these properties, and among them they should have, they have a density attribute. Now our particles have a density attribute, and we saw earlier how the p-scale attribute controls the size of these meshes. So let's put the two together with an attribute remap. So if we search for remap, we have attribute remap here, and we can put it between the randomize and the copy to points. And this allows us to remap an attribute and optionally give it a new name based on this curve. So original name, we can select the density, and for new name we're going to type p-scale, and immediately we can see that our particles now are bigger when they start, and just as the smoke did dissipate, they change in size and fade very quickly, I would say. So this is because, well, the densities are not really thought as size, so it obviously doesn't match one-to-one, but thankfully we have this curve so we can remap this. And since we're doing this change after the simulation, we can change this curve and we don't have to resimulate the whole thing. So let's keep the particles pretty the same size. And just change it at the end. Maybe change these ones to be spline. And this one too, but not this one. Oh. Yeah, maybe something like that. Okay, let's look at it for a moment. We can move forward to. Yeah, I think this is pretty cool. Let me do a quick play blast, or even tweak the settings and come back with a nice render of this, and we'll have some closing words for the tutorial. Well, after a bit of work, this is the final result I ended up with. There are not too many changes after the last time that you saw it. Most of them are tweaks of the simulation parameters here and there to modify small things about how the planes move, but there's nothing huge. I didn't remove or add any new nodes. The other thing I did was to remove the mapping from density to p-scale. If you look at this, the planes are always the same scale. They are just glowing or not glowing, and that's what the density is controlling. So when the density dissipates, the planes go dark. Don't worry too much about that part. I will explain everything about materials and rendering in a future video. The other thing I made, or a change, was I didn't like completely randomizing the colors. Some of the colors that the fully random values generate are not great, and I want a bit more control over that. So let me close this. To do that, instead of randomizing the CD, which is the color of the particles, I'm randomizing this new attribute, which I call call, which has a dimension of 1, which means it's a float that goes from 0 to 1. 0 to 1, max, min and max values. Next, I added a color node and set it to color type ramp from attribute, and selected this new attribute that I created. And now it's mapping this attribute that goes from 0 to 1 to values from this color ramp. And now we can adjust this. For example, we don't want any yellow or any red, and we want just these tones, and maybe we want light pink, maybe like that, and instead of this purple, like a light orange, so we get this like pastel planes. And I think that's a pretty cool way of controlling the color. And that's all I had for today. If you stayed until the end, I hope that you liked the video and enjoyed this view into some of the aspects of Houdini that make this software very special. See you next time!